Welcome back to our channel and the next session of operating systems. In today's session, we will see about the evolution of operating system. How did the software started? At what medium? In which year did it start? How did it change according to the decades? And how many types of systems have been changed? And how these systems have been in use, and how did the program start. Okay, before going to the topic, welcome back to our Easy BTech and beyond. Here, if we talk about the evolution of operating systems, there are many types of systems wherein we will discuss about 7 to 8 in this session, like serial processing, simple batch system, microprogram system or multi-program system, time sharing systems, personal computer systems, and multiprocessor systems. Likewise, distributed systems and real-time systems. Okay. Now, first, let us see how your serial processing was used in the year somewhere around 1940s and 1950s. Okay. The system was nearly room was filled with the system, and user has to access the computer in series. Users would access the computer in series. What does series mean here? Job by job, one job after the other job. Okay, there is no parallel jobs done, or there is no one after the other process. There is nothing like that. Job by job. Once the user job is received, that process has to be done, completed, and it has to be acknowledged to the user. Then they would take the other job, right? The programmer would interact directly with the computer hardware. Now, this is the problem what we have seen when we were discussing about the introduction of operating system. Yes, since the user has to write the program by himself for every job and communicate with the hardware. Since this is a basic problem where it used to take very long time to complete one full job and then moving on to the next job. This was a problem wherein operating system plays a major role here in helping the user and hardware to make the user convenient, and the OS will provide the efficient resources to the hardware to perform each job, right? So the problem here in the year late 1940s and mid 1950s was the programmer used to interact directly with the computer hardware. Okay, these machines were run with a console uh, consisting of display lights, toggle switches, some form of input devices, and printers. And every program in the machine code are loaded into the input device like a card reader, right? Programs in each code, every code was loaded with input devices like card reader. Okay, if when the program was running, there is any error occurred in the program, then the program was halted and the error condition was indicated by a light, so that the programmer who is standing there and performing all these operations or jobs will know that there is some program or error occurred through that blinking light. Okay, if the program is success, then the output will appear on the printer. I think the process was clear. First, user was accessing the computer in a serial form. Serial form is nothing but job by job. And the programmer will interact directly with the computer hardware. And then these machines were run with a console consisting of display lights, toggle switches, some form of input devices and printers. And programs in machine code are loaded with the input device like card readers. And if there is any error while the program is running, then the program was halted and the error condition was indicated by a light. Okay, next, if the program is success, then the output will appear on the printer. Right? Okay, we'll go to the next one, simple batch system. Simple batch system. What is this? Batch processing. This was somewhere used in the year 1959. Okay, around in that decade, not exactly, in that probably 1950s and 60s around. The main use of this. Okay, I will. Now this is the picture of serial processing. Okay, now this is batch processing. Right, batch processing. What happens here? This is generally used to speed up processing. Jobs with similar needs are batched together and run as a group. The user has to submit a job, an operator which places a batch of serial jobs on an input device. Now here you have n number of users. Each user will be giving one request to the operator. A request is nothing but a job. Okay. Now the operator takes all the jobs and it will segregate into batches. Like, for example, we have branches in BTech. All CSE will be grouped to 1, all EC will be grouped to 1, all MEC will be grouped to 1, EEE. Same as the others. Same thing, the operator here will take all the requests from the user and it will segregate the jobs in a batch form. The user has to submit a job to the operator which places a batch of serial jobs on an input device. Okay. Then a special program will run where the monitor manages the execution of each program in a batch. Now your monitor will take the request which program or job has been executed first and which is waiting in the queue. That will be displayed on your monitor first. Okay, that is batch processing. Batch processing clearly tells that this job of execution of multiple programs is done in the form of batches. All these processes internally is done by an operator. Done? Okay. Now let's move on to the next. That is multiprogramming systems. Multiprogramming systems. This was around 1965. This process was probably run in the around 1965. In this, the operating system picks up and begins to execute one of the jobs from group of jobs in a memory. It will have multiple requests, multiple jobs to execute. So it will pick one in a random manner and it will execute that job first. Once the job needs an IO operation, OS switches to another job, right? I am doing one job, say, for example, you are going to a function. Then what happens? Suddenly that you are ready and you are waiting to start off from the house and suddenly you have to wait for somebody else to get ready and come back. What will you do? You have to wait. So in this wait time, operating system will engage with some other job, some other work. It will not waste time. Since it is waiting for somebody, it will take another job and it will execute the other job. I mean, it will start working on the other job. Here, waiting is nothing but waiting for IO operations. Right? If several jobs are ready to run at the same time, then the system chooses which one to run through the process of CPU scheduling. right? If microprogramming in microprogramming system, CPU will never be idle and keeps on processing. It will not be idle in any stage, right? It will keep on processing. I think it is clear. Next is, we'll move on to the next one, time sharing system. This time sharing system was used in the year 1965. What is time sharing system? Time sharing or multitasking is a logical extension of multiprogramming. This is logical extension. We have seen what is multiprogramming. Multiprogramming is while doing one task, if there is any pause during the job execution for waiting for any IO operations to be got into, then my my operating system will take another job during the waiting time, and it will keep on executing. It will not be waiting for, it will not be in an idle stage for a long time, or it will not be in a waiting time, in an idle time. Okay, so this time sharing system is a logical extension of multiprogramming. Like processors time, which is shared among multiple users simultaneously, is termed as time sharing. Processors time, which is shared among multiple users simultaneously. Ante, I have some data, I have some information with me. Now I will be sharing this information with the people who are needed. Say for example, a person A has come to me and he was asking for the information which I have. I will share the content with the person A. After some time, he will finish his work, he will leave, and then the other person comes and he'll tell, I also want the information which you have. Can you help me out with the information? Yes, I will share with him also, right? With the B person. Next, likewise, whoever needs the information will come, use the information and go, right? So time sharing is nothing but processor's time, which is shared among multiple users simultaneously. One after the simultaneously is termed as time sharing. What is the objective here? The main objective here is to maximize processor's use, whereas the objective is to minimize response time. Okay. The time sharing main objective is to maximize processor use and to minimize response time. Multiple jobs are executed by the CPU by switching between them, but the switches occur so frequently. I am using it. I have given to one. Next comes in use. I will give it to the other user. Next. Likewise, one will be in a ready state to come and ask information. The other user will be in an active stage to execute it. One will be, reading or fetching the information from the CPU and so on, right? So, this switches will occur very frequently. Okay. Next, desktop system or personal computer system. From so big system, it has been minimized, and finally it has come to a desktop, right? Which is also called as PC, personal computer system. This was used in the years somewhere like 1970s. Here what happens? My computer system is dedicated to a single user called a personal computer. Now if you ask, what are you doing? I am working on my PC. Okay, now one user will have one PC. What is the goal here? Goal is to have change to its time. Instead of maximizing CPU and peripheral utilization, the system develops for maximizing user convenience and responsiveness. User convenience and responsiveness. The hardware costs for microcomputers are sufficiently low. All the whatever hardware resources should have been there, that is sufficiently low. For example, MS-DOS, Microsoft Windows, Apple Macintosh, likewise. Okay, next, let's move on to the next evolution is multiprocessor system. Multiprocessor system was used in the year 1970s. What is this multiprocessor system? What it has? What is this? What is so special that we have to talk about this? Is it consists of several processors. It consists of several processors that share a common physical memory. All the processors which are there will be sharing a single memory. Okay, like multiprocessor system provides higher computing power and speed. This will provide higher computing power and speed. All the processors operate under single operating system. All the processors operate under single processing system, and multiplicity of the processors and how they do act together are transparent to the others. Right? Everybody knows what kind of operation are they doing, what request are they doing, what from where the data they are fetching, what kind of data they are fetching. All the processors are well aware of. What are the basic advantages in this? Is it enhances the performance. Enhanced performance, it is very clear what the operation it is doing, and the execution of several tasks by different processors concurrently increases the system throughput without spreading up the execution of a single task. Okay, it will not spread when it is executing a single task, right? Next, distributed operating system. This was also used in the years in the same decades of 1970s. In this, what happens? The different machines are connected to a network. Different machines are connected to a network, and each machine has its own processor and owns local memory. In the system, the OS on all the machines work together. They work together to manage the collective network resources. Right? I think it is very clear. You can see the diagram from node 1 to node 5. You have a connection between all the nodes. Right? That's the communication network. Here it is very clear that different machines are connected to a network, and each machine has its own processor and its own memory. And OS on all the machines work together to manage the collective network resources. Okay. What are the advantages here? What are the advantages? User at one side can utilize the resources of system at other side for resource intensive tasks. Likewise, it is fast processing, and my host machine will have a less load. Host machine will have a less load. These are the basic advantages. Okay, next. Right. Now here we have another two types, client server system and peer-to-peer system. How does this work? Client server system is a centralized system which acts as server system, to satisfy requests generated by client systems. I repeat, in this client server system, the centralized system ఏదైతే ఉంటుందో that will act as a server. Okay, I have a server there wherein this server is taking all the requests from the client through a network, and it will satisfy all the requests which are generated by a client system. That is called a client server system. Okay. Now, what is peer-to-peer system? Peer-to-peer system tells each node has its own local memory. Each node has its own local memory, and each node communicates with one another. Each node will communicate with one another through various communication lines, such as high-speed buses or telephone lines, so on. Right? Peer-to-peer system tells that each node has its own memory, local memory, and each node communicates with one another through several communication lines, like high-speed buses or telephone lines. The last one, I think this is the last one, yes, is real-time systems, which is also called as RTOS, real-time operating systems. What is this? The real-time system has well-defined and fixed time constraints. What is fixed time constraints? Is nothing but your deadline. Okay, you have to complete on this date, you have to complete it. That's called time constraints. Now, the OS which guarantees the maximum time for critical operations and complete them on time are referred to as real-time operating systems. What are the examples? Like aircraft systems, medical critical care systems, rocket launching stations, nuclear systems, and so on. These are the real-time examples uh, in RTOS. Okay. I think today's session is all about evolution of operating systems. You have got an idea of how the operating systems have been changed from 1940s to present OS, and how is it used in your mobile devices, telephone, your tabs, your televisions, and so on. Right? For more such sessions, please do subscribe to our channel, Easy BTech and beyond. Thank you.